Alrighty then. So with this, we'll begin a new section and a fresh module to this part of the course. And this section or module is going to be centered around something that's called as Model Context Protocol, which is MCP. So we'll, in general, take a look at what MCP is as a concept, and then we'll take a look at how we can integrate it with the Azure AI Foundry or the Azure AI Agent Service and the Azure AI world in general. All right. So to understand MCP a bit, let's take the help of a real life example, uh, which I'll explain you with this slide and the next following slide. So let's say this is me, Kuljot, which is me, is building an agent that could perform real-time searches with one of the use cases being fetching weather data from a real-time API. And to do this capability before MCP, what we had to do was take an LLM and introduce function calling into that LLM. And with function calling, what you needed to do in function calling was to specify this kind of structure that you could give to the LLM, which includes the name of the function, the description of this tool that the LLM should read, and make a decision whether it wants to call this tool or not. So if the tool name is getWeather, a function would be defined as a Pythonic code snippet with the name of getWeather. The description would be retrieve real-time weather information or data about a particular location or place. So that means if the user inquires about the need to fetch real-time weather information about a particular location, the LLM should invoke that function. And then, based upon what parameters need to be introduced into the respective API call, you also would define the parameters and maybe, the payload that goes into the body part of that API call with, in this case, being location, which would be of type string and the description. So this part was fed into the LLM. You had to define this a single time, and then you could build a bunch of functions, in this case fetching weather information being one of them. And now the API calling part would be defined like this, right? In which you'll define the URL, you'll define what the body payload should look like, you'll define how these URLs need to be hit in succession. So in this case, I hit the first URL, which is to fetch the latitude and longitude coordinates of the location, and the second URL builds up in a way that I would want to use the latitude and longitude coordinates to define a location that I'm interested in, and then get back the weather description for that particular location. Now, there's a very fundamental problem with this. Now, because you aren't the developer of this particular weather API, what happens if either, God knows what, either the URL path could change or even the response types could change. Now, if this happens in an overnight fashion, this will in fact break your application as a whole, because you aren't the API developer, you aren't the uh, API moderator, you aren't the API maintainer, and that's the reason why you won't be notified of that change. And what would happen is your application would break, right? If the response body changes, the response parsing that happens over here would break. Now, this is a very fundamental problem. Now, to solve this problem, the solution is Model Context Protocol, right? So Kuljot learns that overnight the API methods changed. Either the query parameters could change, the payload structure could change, or even the response format could change. Now, this essentially means his AI agent is now good for nothing, right? And this is absolutely not a good sign. And a solution to this problem is MCP, which is called as Model Context Protocol. So now let's try to understand MCP in a better and detailed manner now that we have some sort of an introduction to the problem statement that MCP is trying to solve. So that's a very beautiful visual that I took up from the internet. And all in all, the solution that MCP rather puts forward is the fact that the API call that you saw right now, right? This API call, that wouldn't have to be written in your custom Python code by you as a developer. Now, what would essentially happen is you would receive an MCP server, and this MCP server will be developed by the developer who is developing that API or by the maintainer who is maintaining that API. And because now that you have a server, you wouldn't have to write this custom Python code snippet. You wouldn't even have to write this function calling description capability, supposedly. And then you can take up that server, either run that server as a Dockerized image, or that server could also be locally run, or that server could also be remotely run, right? That server could be hosted online, and then you can make a call to that server, and that's it. This API code that you see over here, the API calling code, will be included in that server. And because that's included in that server, this API code will be maintained or rather developed by the developer or maintainer who's developing that API. And what this means is, even if anything changes in this API, that will be maintained by the developer who is maintaining that MCP server, so that the management overhead is taken from your shoulders, and overnight your application doesn't break. So MCP has the potential to function as a universal interface, and you can think of it as the virtual software version of USB-C for AI, right? So what I mean by USB-C for AI is you at least have an MCP server, and you could pass on that MCP server to your LLM in a very plug and play fashion, just as simple as attaching a USB-C cord. Right? So if you have, let's say, a Gmail MCP server, this Gmail MCP server will be maintained and developed by the developers that are working for the Gmail team at Google. And what you need to do is, if that MCP server is hosted remotely on the internet, you just need to ensure that you pass uh, that remote URL to the LLM, and you wouldn't have to maintain those API calls by yourself. An MCP uses a client server architecture where MCP hosts, which are the AI applications, communicate with MCP servers, right? And these MCP servers could either be locally run as Docker containers if data privacy is your concern, uh, or even these could be remotely hosted if you know you don't want things to run in local fashion. And similarly, because MCP is driven by the open source community, you already have a lot of MCP servers, and a bunch of them being the Gmail server, the Slack server, a couple of web APIs. There could be an MCP server for the weather API that we had a look at in the example, in the previous example. Even for interacting with databases, I think there's an MCP server for, MongoDB and PostgreSQL database also, and then the GitHub server. And if you see this server, the local file system, this is an MCP server that's been developed and maintained by the open source community that you could locally run. So what happens in this local file system server is you take the Docker image, right, that's hosted and maintained by the open source community, and you simply run Docker on your device and run this Dockerized image on that Docker, and then simply pass that Docker image as an MCP server to the LLM. And now what happens is, if you type in the LLM, please rename the file that is stored in my downloads folder from name A to name B, it's going to do that for you. And everything happens locally so that your data stays within your desktop and it's compliant in all sense. Whereas this Gmail API and even the GitHub API, you also have these Docker images for the Gmail API and the GitHub API. But then these are also remotely hosted, if I'm not mistaken. So now that we had an introduction to the problem statement and even discussed a bit about what MCPs are, who's going to maintain these MCP servers, what it means for us as developers. Now let's try to summarize everything and break things in a simpler fashion in digestible bits and pieces. Right. So over here in the example, the visual that I developed, uh, I have an example that encompasses the Gmail MCP server. So earlier, what would happen is I would have to hard code these Gmail APIs in a code that looks something like this, right? And if in case the Gmail API changes, my AI agent would break. But now that I have an MCP server, the Gmail team at Google will maintain these Gmail MCP servers, right? And the Gmail MCP server would be nothing but API calls that could be integrated in LLM tool calling. So it's at the end of the day, it's a wrapper on top of that LLM tool calling that we saw earlier. But this time, the good news is that these MCP servers are maintained by Google devs. So if in case a change happens overnight, my AI application wouldn't break because that Gmail developer would in fact make a change uh, in the MCP server itself, right? And then because my LLM just uses the MCP server, it's good to go. And what this means for Kuljot or rather me is, or even for us developers, is the fact that we can now use these API calls in a very plug and play fashion without needing to worry about making timely API method updates in the function calls for the LLM. So even if the API changes overnight, we can sleep peacefully. Is what I think MCP servers will rather do for us. So just again, as I said, MCP servers can be run remotely. So when I say remotely, I mean uh, you could host an MCP server over the internet, and then your client or rather LLM application could make a connection to that MCP server that is hosted over the internet. But if in case you want to remain uh, privacy safe and have some compliance checks in place, you do not want to send your data over to the internet. These MCP servers could also run locally, and I think in the labs or rather the demos that we'll do, we'll run a GitHub MCP server locally, and I think we'll also do the Gmail API one if I'm not sure, but we'll definitely do the GitHub MCP server locally. So in local MCP servers, you get a Dockerized image, and then you can run the Dockerized image in on your local device on your local desktop, and that stays compliant. In fact, with all of your private data. Uh, but even though I think coming to this slide, MCP servers have a lot of advantage, but the time that I've experimented with these MCP servers, I still believe these are very crude in nature and not at all developer friendly, right? So MCP servers are quite difficult to implement. These are what I feel not that developer friendly and are quite a pain to implement right now with all the tool sets. But this statement is for the people who are developing these MCP servers. And I feel a lot of developers will rather use these MCP servers in a plug and play fashion. So this statement, it's MCP servers development is a pain for, let's say the developer at the Gmail API, who's developing the Gmail API MCP server. But these MCP servers are not a pain for me, who's going to be just using the Gmail API MCP server in a very plug and play fashion. Right? So this would essentially mean more work for these Gmail or GitHub MCP devs, but less work for us than before, which is rather a very much added advantage for developers like us. But still, I feel, even though these are quite a pain for these Gmail or GitHub devs, the thought behind this is very optimistic, but I think it still has a quite a long way to go. Uh, and at the end of the day, you have a beautiful instructor, an amazing instructor like Kuljot to guide you through. And if that's the case, what's the worry? I'm just gonna make sure that I can break down things in as simple as a manner possible, and I'll do my level best, and I'm pretty sure I won't leave you guys disappointed. All right, so that's pretty much it about the introduction and a bit of discussion over the MCP servers and MCP concepts in general. That's pretty much it. Without further ado, let's quickly move on to the next set of videos.